Hello. In this video, we're going to take a look at inverse function and its property. Now, the inverse function is quite simply the opposite or reverse function of the original. Now, it will switch the role of the x and y. So it's going to switch the role of both the independent and dependent values. So we're going to switch them up. And we also have this notation of, instead of f of x, we have f to the negative 1x as the notation for our inverse function of f of x, whatever it is. So that's going to be our notation, and we're going to take a look at a couple of examples and two different methods of how we determine the inverse function. So this one, we want to find the inverse function of f of x is equal to 2x plus 5. 2x plus 5 is a straightforward linear function, and we're going to find the inverse function of this. Now, the first method we're going to look at is called the inverse operations or reverse bedmass. So bedmass is our order of operations. So this is essentially what I call SAMDEB. So it's the opposite of what we usually do. So we look at our function 2x plus 5 and we go the opposite order of operations. So the first thing we're going to do is we're going to look at the addition and subtraction. So in this case, we're adding 5. So for the inverse function, we're going to subtract 5. And now we're also multiplying x by 2, so we're going to divide x by 2. So then we just apply these two steps to x, because that's all there is to this point. So my inverse function for f of x is going to be x subtract 5 divide by 2. And that gives me my inverse function. Now the other way to approach it is to switch the x and y values, because that's essentially what an inverse function has done. So we write out our function in terms of x and y. So we have y is equal to 2x plus 5. Then we rewrite it with x and y switched. So x is equal to 2y plus 5. From here, we just isolate for x, like any normal algebraic equation. So I have plus 5 here, to bring it on over, I have x minus 5, now equal to 2y. If I want to get rid of y, or sorry, bring it down to 1y, divide both sides by 2, and I get x minus 5 divided by 2 equal to y, and therefore x minus 5 divided by 2 is equal to my inverse function, f minus 5. Let's take a look at another example. In this case, I have g of x is equal to 2 times x minus 1 squared plus 3. So looking at our kind of SAMDEB, well, first thing we got to take care of is the addition and subtraction here of plus 3. So opposite of plus 3 is subtract 3. We're also, again, multiplying by 2, so the opposite of that is divide by 2. Now moving on, because we have no more multiplication division, we have exponent. So we have an exponent here of 2. So the opposite of something being squared is square root. And inside the brackets, we have x minus 1. So the last thing we do is the opposite of x minus 1. We actually add 1. So we're going to add 1. In the end, we get an inverse function. So I start off with x. First thing I do is subtract 3. Second thing is divide by 2. Then I'm going to square root the whole thing. And then I'm going to add 1. And I have my inverse function for that. Now, also for completeness, let's try it with the switching of the x and y variable. So I first have to put it into terms of y and x. So I have 2x minus 1 squared plus 3. Switch the x and y, so x is equal to 2x minus 1 squared plus 3. Oh, sorry, that's y. So x minus 3 is equal to 2y minus 1 squared, divided by 2, divided by 2, y minus 1 squared, square root, x minus 3 over 2 is equal to y minus 1. Bring the 1 over. I have x minus 3 over 2 plus 1 equal to y, which is also equal to my inverse function. So those are the two methods. Either doing the SAMDEB or reverse BEDMAS, or we can just switch the x and y value and then isolate for y back again. So beyond that, we want to see what happens when we graph the function in its inverse. So right now I have this function f of x is equal to 3x plus 1, and its inverse for that is going to be equal to x minus 1 over 3. So I just done the reverse BEDMAS. So this is going to be equal, essentially, just in a more y equals mx plus b notation, I have x over 3 minus 1 over 3. Alright, so I'm going to let's do this one right here. Well, I'll keep it in black. So I have 3x plus 1, so I'm starting at 1. And I'm going up 3 over 1, up 3 over 1, up 3 over 1. And we can do the same thing over here. Down, down, down like that. So that gives me those kinds of points. I'm just going to kind of get a line here. Yeah, I'll get this nice black line. And I'm just going to go like this. Yep, there we go. There's my line. Now for the other one, which I'm going to do in blue, I have 1 over 3x minus 1 over 3, so negative 1 over 3 is probably going to be somewhere here. And then I'm going to go over 1, 2, 3, and then up 1. So it's going to be like right around here. Right, so right around here. Over 3, up 1, over 3, up 1, kind of reverse here, sort of like that. Do it again. There, getting all those points. Again, I'm going to use my line kind of thing. Oh, this one just happens to be blue, so I'll use this one. So it's kind of like that. And that's fine. So we see that they kind of intersect, but they're going to intersect at a very specific line. They're going to actually intersect along the y equals x line. So it's essentially this line here. This green line here. So it's going to be this line right here, corner to corner. So we can just see, just down here, like that, that it intersects right here on that line, just kind of right around there. So a function and its reverse will always intersect along the kind of y equals x line. And this also gives us a very important property. And this property allows us to check whether or not we've done our inverse correctly. So this property is that if I take f of f minus 1 of the x is going to equal x. So if we take a look at we had an f of x before of 2x plus 5, and figured out that f of minus 1 of x was equal to x minus 5 over 2. So to do this kind of f of minus 1 at x, I'm actually going to put this one in the place of x. So f of f minus 1 x, well, that's going to be equal to 2 times x minus 5 over 2 plus 5. See? I've essentially just kind of nested it in where x should be. So, looking at it straight off the bat, 2 and 2 will cancel out. So I'm left with x minus 5 plus 5. Well, hey, negative 5 plus 5. I'm left with x, and that satisfies the conditions for my inverse function, so I know that's correct. So we've checked it two ways. We checked it by graphing, so it intersects along the y equals x line, and now we've also checked it algebraically by kind of subbing it in using the f of minus 1x equals x kind of formula. So that's the inverse function, or at least an introduction to it, and some of its properties.